Let us revise all three laws of motion, concept of momentum and impulse in this class. We have already done all these concepts in detail. Newton's first law, of motion, which is also called the law of inertia, initially given by Galileo. It talks about the inertial property of the body. It tells that a body has a tendency to keep on moving with same speed in same direction of motion if left undisturbed. So the velocity will not change, means the body will continue to move with same speed in same direction if there is no external force acting onto it. So no change in speed or direction of motion means there can't be any acceleration. So acceleration of the body is zero if external force onto it is zero. If there is any force, there will be an acceleration. So we can say there can't be any acceleration without a force. This is first law. And then we have inertia of motion, inertia of direction, inertia of rest. They all are related. Inertia of rest means a body will have a tendency to remain at rest. Inertia of motion means a body has a tendency to remain in motion. Inertia of direction means the body has a tendency to continue move continuously in the same direction if there is no force. So inertia of motion, inertia of direction, inertia of rest. There can't be any acceleration without a force. Acceleration is zero. No change in speed, no change in direction if there is no force. This is first law. Then we define the concept of momentum. Product of mass and velocity. It's a vector quantity having the same direction as of velocity. It is needed to define force actually. The first law says that there can't be any acceleration without a force. It means we need a force if we want to change the velocity of the body. Now on what other factors the force will depend? It depends on the mass of the body. It depends how much change we want to produce in the body, and it also depends on the time in which we want to bring about this change. Means how quickly we want to change the speed. Force will depend on that also. And Newton's second law basically tells us that force is proportional to the rate of change of momentum, del P upon del T, and in SI units, this constant of proportionality has been chosen as 1. So F is del P by del T. This is Newton's second law of motion. Force acting on a body is directly proportional to the rate of change of momentum. We can also write it dP by dt. For a smaller interval, if the force acting is changing, then we have to choose a very small interval of time. For that interval, if the change in momentum is just dP, so F is dP by dt. P is mass into velocity. So I can also write it d by dt mv. If mass is constant, it becomes m dv by dt, and it is m into a. If m is constant. So see, F is always equal to dP by dt, but F is equal to ma only when the mass of the body is constant. Otherwise, we need to use dP by dt. Now this is again saying the same thing. If F is 0, A is 0. So there can't be any acceleration without force. This was Newton's first law also. So second law actually is mathematical formulation of the first law. But it tells many other things also. F is equal to ma if I take it in vector form. So whenever there is a force, there will be an acceleration. And acceleration is always in the same direction as of force. If we apply the same force on different bodies, same force on bodies of different masses, then acceleration will be different. Acceleration will be inversely proportional to mass for same force, which means heavy bodies accelerate less. Lighter bodies will accelerate more. So if you are trying to push a body, how much acceleration will be produced, it will depend on its mass. Heavier bodies, less change. It means they opposes more. So we also come to know about one more property from second law, the inertial property that we talked about in law of inertia. Mass is a measure of inertial property of the body. So all bodies have inertia, inertia of rest, inertia of motion, inertia of direction, and that inertial property actually depends on the mass of the body. So mass is a measure of inertia that we come to know from Newton's second law. Okay, and to produce same acceleration in bodies of different masses, we will need different force. Heavier bodies need more force, lighter bodies need less force. Then we can also talk about the units of force using this. F is equal to ma mlt minus 2. This is the dimensional formula for force, and unit will be kg meter per second square. It is also called 1 Newton. So 1 Newton is that force which produces an acceleration of 1 kilogram per meter square in a body of mass 1 kilogram. Dyne is a unit of force in series. So 1 dyne is 1 gram centimeter per second square. That force which produces an acceleration of 1 centimeter per second square in a body of mass 1 gram, that is called 1 dyne. We can find a relation also between the two. We have done in the first topic dimensions. Okay. There is another unit, kg force. 1 kilogram force means 9.8 Newton. This is another unit of force. Okay, then Newton's third law, action and reaction. Law of action and reaction. Every action has an equal and opposite reaction, which means forces always occur in pairs. Every force will have a reaction. So if a body A applies a force on body B, suppose we are pushing A is pushing B, and it is moving hot. So A is pushing B, B will push this. So there will be a force on B, F on B due to A, and there will be a force on A due to B, and I can write FAB is minus FBA. Every action has an equal and opposite reaction. They are equal in magnitude, opposite in direction, and they never cancel. This is one of the very important things, right? If action reaction are equal and opposite, it doesn't mean that the net force will be zero, because both of them are acting on different bodies. This force is acting on this force is acting on this. So they, action and reaction pair will never cancel. This is Newton's third law. Then we have also talked about the law of conservation of momentum. We have defined Newton's law like this. Second law. Force acting on a body is equal to the rate of change of momentum. For a particle, it has been defined. So for a particle, F is dp by dt. So if F is 0, dP is 0, which means P is constant or mv is constant. How can we state it? If there is no force acting on a particle, its momentum remains constant. This is again the first law. A body will continue to move with the same velocity if there is no force acting onto it. So if there is no force, the momentum will remain constant, the law of conservation of momentum. But this is only for a particle. If we have to define it for a body, then we have to include internal forces also. See how this law gets modified. Let me take only two particle system, 1 and 2. This is a body having just 2 particles. Then we can generalize it for many particles. So what will be the total force? There can be some external force, and then this may be applying some force onto it, this may be applying some force onto it. So how F total, how much? F external plus force on 1 due to 2 plus force on 2 due to 1. These are internal forces. So how can I write Newton's law? dP by dt, and this also becomes d by dt P1 plus P2 because there are 2 particles. So the momentum of both. This can be written as F external. We have done all these, I am just revising. It is d by dt P1 plus P2. Okay. Now it is for a system of particles. If I have collection of particles, many particles, then I have to include all the pairs, F12, F13, F14 and so on, so on. But Newton's third law actually makes it very simple. Every action has an equal and opposite reaction. So this will always be, if whatever force this is applying onto it, this will apply equal and opposite force onto it. So what will be the sum of these two? This will always be 0. So this is 0. So how it reduces to now? So F external is equal to internal forces don't occur in it. So how can I state this now? If F external is 0, then D P1 plus P2 is 0, which means P1 plus P2 is constant. What does it mean? If there are no external forces acting on a system, then the momentum of the system remains constant. It means internal forces cannot change the momentum of the body. We always need some external force to change the momentum. Internal forces can never change. And if we have done many examples, like for example when bullets are fired using a gun. So now there is no external force. We can take the system as bullet and guns. So whatever momentum the bullets acquire in one direction, the gun will acquire equal momentum because there is no external force. So P1 plus P2 is 0. So whatever momentum, if this has momentum mv and this has capital MV, then mv is minus mv, equal and opposite. So whatever momentum this is acquiring in equal, this will acquire equal momentum in opposite direction. Net momentum will still be 0. Before firing the bullets, net momentum is 0. After firing also it will remain 0. So if one is moving in one direction, another body will move in opposite direction to keep the momentum 0. We need some external force to change the momentum, and we can have many other examples too. There is another concept that has been used, impulse and impulsive forces. Impulsive forces are those forces which act for a very short interval of time and are very large, such as in collisions. So whenever one particle collides with the other, or a particular body collides with the other, then a very large force acts, but the duration of that force is very small. So from second law again, F dt is dp. So impulsive force is that force which acts for a very short interval of time, and impulse is this quantity. So change in momentum is called impulse. This is for a very short interval of time. If we need to calculate it for a larger interval, we can integrate it. And if we have a graph F versus T, then product integration. So it will be the area under the graph. That will give us the value of impulse if we are using this graph. Now this concept is also used in many daily life experiences actually. If we have to catch a ball, cricket players, they have to catch a ball, it means they have to stop a ball. Suppose it is moving with the velocity v and finally it is to be stopped. So change in velocity is v. This is change in velocity. Now from here it has certain mass. F is dp by dt. F dt is dp. For a certain given value of change in momentum, force, we need to apply force to change the momentum, whether we want to stop a body or we want to set it in motion. And to cause a particular change in momentum, we need to apply force. How much force we need to apply, that depends on the time taken to accelerate or to stop a body. So if we have to stop a moving ball, then change in momentum is given. It has a certain mass, certain velocity, you have to stop it. So that quantity dp or del p is fixed. You will need large force if you stop it in very short interval of time, but you may need lesser force if you increase the time required to stop it. So if you drag your hands backward to stop the ball, you need less effort. You have to apply lesser force. But if you stop it like this, immediately, without dragging your hands back, so you are trying to stop the body instantly in a very short interval of time, so that may need more force. Same thing, you might have experienced that if you jump on a cemented floor, then you are more likely to hurt when in comparison to when you jump on a floor that is not cemented, that is soft. Suppose you put some cushions and then you jump onto it. So it will take time to stop you because they will be pressed. So the time is increased in which you come to rest. If this is increased, then force of impact, impulsive force, is reduced. Okay, so that's all. We have revised law of inertia, Newton's first law, then Newton's second law. F is equal to ma for bodies of constant mass, otherwise F is equal to dp by dt. Every action has an equal and opposite reaction. They act simultaneously but on different bodies, don't cancel out. Law of conservation of momentum for a particle: if there is no force, the momentum of the particle remains constant. And for a system of particles or for a body, if there is no external force, then the momentum remains constant. Impulsive force is the force that acts on a body for a short interval of time, and impulse is the product of the force and the time interval for which you apply the force. So F into T, that is impulse, which is equal to the change in momentum.